Saturn is not the only planet with rings. Neptune, Uranus, and Jupiter have them too. Check this out. Even though Neptune is so far, we still got the clearest view of its rings over the past 30 years. And check out good old Uranus. It comes with 2 sets of rings. The inner system consists of 9 rings that are mostly dark gray and pretty narrow. There are 2 outer rings. The outermost one is blue, like one of Saturn's rings, while the innermost one is reddish, just like some dusty rings you'd find in other spots in our solar system. Jupiter's not bad either. Its rings are made up of small dust particles and are so faint that we can only see them when they get lit by the sun or when we observe them directly in infrared light. There's an interesting story about how Jupiter got its rings. The dust the rings consist of formed when micrometeors, which are tiny pieces of rock and debris, hit the small moons around Jupiter. As expected, these impacts made a mess and threw up dust into space. Jupiter obviously saw its chance to get itself some nice rings, so it captured dust into its orbit. These particles of dust are really small because if the impacts were any bigger, gravity would pull the larger pieces back down to the surface of the moons. And these micrometeors keep hitting the moons and add more dust to these rings, so they always keep fresh and a bit new. Okay, cool story, but none of these planets have spectacular rings like Saturn. They're made up of small particles of ice, rock, and dust. And these pieces probably came from asteroids, comets, or moons that broke apart before they even got to Saturn because of its strong gravity. What makes Saturn's rings so special is that they're made of many tiny particles that reflect a lot of light. This is why they're visible, even with an average telescope that amateur astronomers use. When we look through the telescope, we can see the rings clearly because they're big and bright. And these chunks in the rings range in size from tiny dust grains to those as large as a house. And if we could look at those rings, we'd see some of the particles as big as entire mountains. Wow, imagine if you could sit at the top of it and enjoy the roller coaster ride around Saturn. If you could look at the rings from the cloud tops of Saturn, they would mostly appear white. Plus, each of its rings moves at its own speed. Wow, stunning, right? But the news up there is not so good. It seems that these fascinating rings are disappearing. In fact, ever since the 1980s, astronomers have known these rings are getting smaller as time goes by. It appears that the particles from the rings are actually raining down onto Saturn's atmosphere. Not just raining. Every day, an amount of water you'd find in an Olympic-sized swimming pool falls onto Saturn. But scientists are still not quite sure how quickly these rings are disappearing and when they will be completely gone. And to see this, we have NASA's James Webb Space Telescope, JWST, and the Keck Observatory in Hawaii that will study Saturn over a long period of time. They will track what exactly happens with this ring rain and how it changes during one full season on Saturn. That's about 7 Earth years. And a lot of ring material is falling onto Saturn all the time. Somewhere between 880 and 6,000 pounds of icy rain flows onto the gas giant every second. And by this, it's heating up its upper atmosphere. If this keeps happening at the same rate, Saturn's rings might disappear in about 300 million years. Hope humankind will get at least one roller coaster ride before they're gone, though. But while this may seem long to us, in terms of space, it's relatively quick. But this rate could slow down through time, so the rings might be there for more than 1 billion years. Or, if they start disappearing faster, about 100 million years. It's not like this process happens by itself. Space rocks and the radiation coming from our sun affect all those particles in the rings. They give the particles an electrical charge. This charge causes them to stick to Saturn's magnetic field lines. Saturn's mighty gravity then pulls these icy particles in, and they flow into its upper atmosphere. Saturn goes around the sun once every 29.5 years. As it's making its circle, it moves closer to and farther away from the Sun, and its rings do the same. This tilt affects how much the Sun's radiation affects the deepest layers of the planet's rings, which is where most of the icy rain comes from. Scientists think that when the rings are tilted to face the Sun, there will be more material falling onto Saturn. But when the rings are edge-on with the Sun, the material falling onto Saturn slows down. Scientists are not only trying to predict the fate of Saturn's rings, but they also still debate when and how they even formed. Some theories say the rings have been around ever since our solar system formed billions of years ago. But the Cassini spacecraft explored Saturn and brought some data that encouraged the idea that the rings are way younger than that, maybe 10 million to 100 million years old. Another interesting idea says the heavy rain from the rings might make them look younger than they actually are. Whoa, did those rings find their own fountain of youth? But I'm afraid not even that can make the rings last forever. Sooner or later, Saturn will have to face an identity crisis when it loses its beautiful rings. At some point, it seemed this year wasn't so good for Saturn, because another one of the planets was quickly heading to take the title of the one with the largest number of satellites. In February of 2023, scientists discovered 12 new Jupiter moons, and Jupiter overtook Saturn to become the leader in the number of moons. These moons accidentally popped out while they were looking for Planet 9. You know, that one hypothetical planet that could be lurking somewhere in the outer region of our solar system. And these newly found moons are kinda dim and small, but they couldn't hide from our powerful telescope and the advanced techniques scientists use to spot them. What's interesting is that 9 of the new moons orbit Jupiter in the opposite direction of its rotation, while the other 3 orbit in the same direction. What happened to those fellas? Do they even know they got into the wrong lane? Some say they could be the remains of bigger bodies that broke apart after hitting some other objects. So typical for space. Now, there's a moon called Valetudo that was discovered a few years ago. Unlike the retrograde moons, Valetudo has a prograde orbit, which means it orbits in the same direction as Jupiter's rotation. What's interesting is that Valetudo moves in an orbit that crosses into the paths of these retrograde moons. Could it be the retrograde moons formed because they collided with prograde moons such as Valetudo at some point? Hopefully, we'll find out. It was a great success for Jupiter, but 3 months later, things changed when they also found 62 satellites circling around Saturn, which means Saturn became the leader again, with 145 moons in total, compared to only 95 of Jupiter's moons. Astronomers have discovered new moons around Saturn using a technique called shift and stack. This means they combined multiple images that shift along with the moon's movement, and this helps to enhance the faint signal from the moon. That's how they discovered even those smaller and dimmer moons they couldn't have previously seen in single images, like those that are 1.6 miles in diameter. They needed to confirm these objects were moons and not some asteroids passing by, so they tracked them for a couple of years to see their orbits around Saturn. So, Saturn may be losing its rings, but there are more moons over there than expected. And who knows how many more interesting things we'll find around it.
You may have heard that NASA will launch a mission to Saturn's largest moon, Titan, in 2028. And, well, a lot can go wrong. The Dragonfly spacecraft will hit a thick atmosphere at insane speed, survive a fiery plunge, hop its parachutes, and then land in a spot way colder than Antarctica. And if you're picturing a giant Star Trek-style spaceship, nah. Dragonfly is basically a high-tech drone, about the size of a Mini Cooper. So, can something that small really survive all that? Well, it better survive, especially since the project is already 2 years behind and keeps getting more expensive. NASA selected the Dragonfly mission in June 2019. and the launch was scheduled for 2026. But now it's been pushed back to 2028. That delay alone added about $1 billion to the total cost. At this point, the project costs over $3 billion. All that money is going into building a nuclear-powered car-sized craft with 8 rotors, kind of like a drone. It'll be fast, able to travel tens of miles in less than an hour, and it will take about 6 years to get to Titan. So, if the current launch date holds, it should land over there by 2034. But why Titan exactly? Well, that's because Titan is weird in the best way. It's Saturn's largest moon. It's also bigger than our own moon and the planet Mercury. Titan's atmosphere is thick. The air pressure there is about 60% higher than Earth's, which is kind of like the pressure you feel at the bottom of a deep swimming pool. But the main reason everyone's so interested in Titan is that it has all the ingredients for life. This world is packed with complex carbon-based chemicals. On Earth, carbon is at the center of all living things. It helps form our cells and body structures, and it's involved in the chemical reactions that keep life running. Without carbon, life as we know it wouldn't exist. Then there's water. Okay, Titan is just too freaking cold to have liquid water, but there's ice. It also has clouds, rain, rivers, lakes, and seas of liquid hydrocarbons like methane and ethane. On top of that, scientists think it might have a liquid water ocean hidden under its icy crust, similar to what we believe exists on Jupiter's moon Europa. In many ways, Titan may resemble what Earth was like billions of years ago before life fully developed into what we see today. By studying Titan's chemistry and environment, scientists hope to spot chemical fingerprints that could point to past or even present life. One of Dragonfly's main targets is the Selk impact crater. Scientists think something slammed into this area a few 100 million years ago, and that impact may have piled up the right ingredients for life in one spot. We're talking about a mix of carbon, plus hydrogen, oxygen, and nitrogen. Now, on paper, this mission sounds amazing. Send a flying robot to Titan to understand how life must have begun. But when you get into the details, you realize just how hard it is. Flying a drone in such a remote world is something relatively new and, honestly, a bit daunting. There's very little room for mistakes. So, over the last few years, scientists have been running all kinds of technical tests. And that's super important, because Dragonfly isn't just getting there and flying back. It's going to spend about 2.5 years operating and exploring different spots around Titan. And since the air there is much thicker than Earth's, Dragonfly's rotors won't behave the same way they do here. If you want to know whether it can lift off, stay steady, and steer properly, you can't just guess or use normal drone experience. You have to recreate Titan's air conditions here on Earth to see how the craft will fly over there. That's why they decided to test it in this huge wind tunnel at NASA's Langley Research Center located in Virginia. But they didn't just blow regular air through it. Instead, they pumped in a gas called R-134 Freon. This gas helps them to imitate the way Titan's thick atmosphere would push and swirl around the rotors. The idea is to test how Dragonfly will handle the air pressure, check its vibrations, that kind of stuff. It was only after running simulations that the problems started to show up. And it turns out Dragonfly had quite a few. From the start, engineers knew the landing on Saturn's moon would be a huge challenge. On Mars, for example, spacecraft go through a fast, intense landing that NASA often calls the 7 minutes of terror. But on Titan, Dragonfly's descent and landing is expected to take much longer, around 2 hours. The descent will be really tough. As Dragonfly drops into Titan's atmosphere, it'll be sealed inside an aeroshell. It's basically a heat shield designed to handle the intense friction and heat during entry. NASA also designed parachutes that will deploy later and slow the spacecraft down bit by bit. These parachutes have to work for a long time, up to 110 minutes. But tests show that the aeroshell could wobble a lot or even start to tumble during that long stretch. So NASA had to adjust the parachutes to help keep the spacecraft stable. After that tough descent, we can all celebrate, right? Well, not yet. Because as soon as the Dragonfly lands on the surface, it could face a different problem – overheating. And that sounds weird, considering Titan is insanely cold, with temperatures that can drop to about minus 290 degrees Fahrenheit. So, at first, scientists thought their main job would be keeping Dragonfly warm while it stays over there. That's why the original plan was to give Dragonfly a special power source called a multi-mission radioisotope thermoelectric generator. Well, that's a mouthful. It's the same kind of nuclear-powered generator used on the Curiosity and Perseverance rovers on Mars, and it provides both electricity and heat. But when researchers ran simulations, they found the design could cause the opposite problem. If there's no wind on Titan, like on a totally calm day, Dragonfly might not be able to get rid of the heat, and then the lander could overheat. In simple terms, even on a freezing world like Titan, that generator could put out enough heat to make parts of Dragonfly too warm. And then, the mission is basically over. Titan's thick atmosphere causes another tricky problem. On Earth, the atmosphere and weather can change pretty quickly because our days and seasons move along fast. But Titan runs on a much slower clock. One full day on Titan lasts about 16 Earth days, and 1 year there takes almost 30 Earth years. Since everything changes so slowly, the atmosphere doesn't shift as suddenly as it can here. And that slow pace affects temperature too. On planets like Mars, the temperature can swing a lot between day and night. Titan isn't like that. Thanks to its dense atmosphere, the temperature stays pretty steady. Now, the changes may be small, but scientists still have to take them seriously. So they put Dragonfly through a series of tests, and it passed. Thankfully, it looks like the craft's heating and cooling system can handle those subtle shifts. Now, you might be wondering, okay, but how does it actually move around? Well, because by now you know Dragonfly is like a drone. I mean, it doesn't have wheels. It has propellers and landing skids, so it can't just drive across the ground. Instead, it's meant to travel by flying. It will take off straight up, fly to a new spot, and land again, over and over. All this makes Dragonfly an amazing engineering project. But because it's so bold, there are still a lot of concerns. That's exactly why NASA is testing everything and taking every precaution to give it the best shot. And if it works, Dragonfly could help us find clues about how life on Earth first began. Maybe we'll find signs of life out there, or maybe discover something even bigger. But it's hard to know what Titan is really hiding for now, so we'll just have to wait for 2034. Attention, attention! Something very exciting is going on Saturn. It's called a spoke season, and no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. They quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place. That's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the Moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the Moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that. This planet is often called the jewel of the solar system, probably because of how beautiful it is and how exotic it looks with colorful rings surrounding it. You've probably already guessed that I'm talking about Saturn, the second largest planet in the solar system. And the question is, can Saturn be a failed star? Now, a failed star is composed of gas, but it can't sustain nuclear fusion reactions in its core because it's not massive enough. This type of star is often referred to as a brown dwarf. Such space bodies are close in size to Jupiter, the largest planet in our solar system, but brown dwarfs have a much greater mass. Unlike other stars, they don't emit a lot of visible light since they aren't large enough to fuse hydrogen, even though brown dwarfs can fuse deuterium with lithium. Failed stars were discovered around 60 years ago. Some of the first theoretical papers describing them were published in 1962. If we talk about the first time astronomers confirmed the existence of a brown dwarf, it happened in 1988 when they spotted a space object later called GD 165b. Despite having a lot of characteristics of a star itself, this celestial body was orbiting another star and didn't meet all the necessary requirements to get this title. That's why scientists started calling it a failed star. Seems kind of harsh now, doesn't it? Since that first discovery, astronomers have spotted more than 50 other brown dwarfs. And according to the latest estimates, there might be around 25 million failed stars in our galaxy alone. Because of the lack of visible light, brown dwarfs are very difficult to spot, so this number might be inaccurate. You think? The most typical reason why a star might fail is that it doesn't manage to gather enough material to start regular stellar fusion. Now back to Saturn. The answer to the question of whether this planet might be a failed star is no. Why? The main difference between a planet and a failed star is the way they form. Stars appear when dust and gas collapse in a primordial cloud. That's why they contain low amounts of metals. At the same time, planets have significantly less mass than stars. That's why they have much lower gravities. And one of the main reasons why Saturn isn't a failed star is that it didn't start its life with enough mass to get the status of a star. A brown dwarf accumulates its star material in a similar way a star does, rather than following the method planets use. Thanks to their high gravity, failed stars can easily hold on to relatively light elements, like helium and hydrogen. For Saturn to become a failed star, it would need to be 50 times its current mass. But even if the gas giant decided to go through with the plan of becoming a brown dwarf, there simply wouldn't be enough material orbiting the Sun for this to happen. Any of the gas giants in our solar system, Jupiter or Saturn, would need at least 10 to 15 times more material to grow into a failed star. Not something you'd normally aspire to. You see, the Sun contains around 99.86% of the mass of the entire solar system. So, even if you combined all other materials in our star system, it still wouldn't be enough to create a star, even a failed one. Brown dwarfs and regular stars have a lot in common. Both start their lives as giant balls of gas. Both have protostellar cores. All of them start nuclear reactions and produce a lot of heat. Many failed stars produce some light too, but it mostly lies in the infrared spectrum. Now, let's look at the differences between these kinds of stars. A regular star releases light and energy due to thermonuclear reactions going on in its core, converting hydrogen into lithium. But a failed star doesn't have the mass to achieve this. Plus, failed stars are much smaller than regular stars, which generally possess more than 80 times the mass of Jupiter. A regular star normally has a gravitational pull strong enough to form a solar system with planets orbiting around it. As for brown dwarfs, they often orbit other stars. There's only one known failed star with a planet orbiting it. And I'm curious, why did scientists call it a failed star? Seems sort of academically judgmental to me. Did it get an F on some exam? How about other labels? Disappointing star or came up short star? But I digress. Okay then, how about Jupiter? After all, this gas giant is larger than Saturn. In fact, it's the largest planet in the solar system. Plus, this planet and the Sun are basically made of the same stuff. Both are mostly composed of hydrogen and helium with traces of other chemicals and elements. But the Sun is over 1,000 times the mass of Jupiter. If you place these two space bodies side by side, the gas giant would look tiny next to our star. So, what makeover would Jupiter need to undergo to turn into a star? If it wanted to be as large as our Sun, it would have to increase its mass by a factor of over 1,000. On the other hand, the Sun isn't the smallest or least massive star out there. There are red dwarfs, stars with the lowest mass. The smallest of them can be a mere 7.5% of the mass of the Sun. So, if Jupiter was striving to be called a star, it would be much more realistic for it to become a red dwarf. In this case, it would have to increase its mass by a factor of 80 or so. Interestingly, there's a tiny star in the Milky Way galaxy which is smaller than Jupiter. This is a red dwarf about 36,660 miles across that lies 600 light-years away from Earth. It makes the red dwarf one of the smallest known stars capable of supporting hydrogen fusion. Okay, we figured out that neither Saturn nor Jupiter can be called a failed star. But what if these two gas giants collided? Would they merge into one gas giant, which would then turn into a brown dwarf? Of course, at the moment, we're unlikely to see Jupiter and Saturn collide, which is a good thing. But let's speak about a hypothetical situation and its consequences. So, some time ago, scientists were sure that Saturn and Jupiter played similar games. At some point in the past, both planets reached the stage where they needed to vacuum up tremendous amounts of material in a relatively short period of time. But apparently, Jupiter got luckier in the process. Still, according to some studies, Saturn never had a running chance. You see, the critical threshold where a planet can gain a huge amount of hydrogen and helium is about 100 times the mass of our planet. And Jupiter indeed easily beats it, which might mean that it managed to acquire the lion's share of material in the outer solar system before the Sun blew it away. Uranus and Neptune turned out to be far too small to take part in this race for power. As for Saturn, it's right in the transition zone. Had it been a bit bigger, it could have probably competed with Jupiter for the title of the largest planet in the solar system. But instead of fighting its main competitor, Saturn got stuck. It grew large enough to attract a significant amount of hydrogen and helium with the help of its gravitational pull. But it wasn't enough to kickstart the process of nuclear fusion and get going. It means that despite all the similarities they share, Jupiter and Saturn evolved along totally different tracks. And if these two planets collided, they wouldn't merge into one planet, let alone a star. If it was a head-on collision, the planets would destroy each other. Their gas envelopes would be eliminated, and the remains of their solid cores would be catapulted into the vacuum of the cosmos. But if the collision happened at an angle, the planets would probably survive it. But in both cases, the planets would lose a massive portion of their material. In one more collision scenario, the gas giants would simply slide across each other at an oblique angle. It would result in a change in their shapes, but wouldn't alter the composition or mass of the planets. Can we call that a failed collision? How disappointing.
This terrifying but very much real image emerged just recently. In it, you can see something that looks like it belongs in a science fiction movie. From far above Earth, aboard the International Space Station, an astronaut captured something astonishing over Louisiana. A gigantic jet blasting upward straight into the sky. It looks as if Earth is sending a signal skyward. Can science explain this eerie phenomenon? Apparently, it can. This energy blast is called a gigantic jet, and it's one of the rarest and most powerful kinds of lightning we know about. Unlike regular lightning, which strikes down toward the ground, gigantic jets shoot up from storm clouds, and they can stretch for more than 50 miles into the sky. Sometimes they even reach the ionosphere, the layer where Earth's atmosphere starts blending into outer space. To give you an idea, space officially starts around 62 miles above sea level, and the ionosphere stretches from about 50 to 400 miles up. Shockingly, scientists have only known about gigantic jets for about 20 years, and we're still figuring out exactly how they work. One theory is that something inside the storm cloud blocks the lightning from escaping downward. So all this pent-up energy looks for another way out and ends up blasting upward into the sky. But honestly, we still don't fully understand why it happens. Gigantic jets are also extremely rare. Scientists think that they happen only around 1,000 times a year on the entire planet. And when they do happen, they carry a lot of energy. We're talking more than 50 times the power of a normal lightning bolt. The strongest gigantic jet ever recorded happened in Oklahoma in May 2018. It was intense, reaching a temperature of 8,000 degrees Fahrenheit and releasing about 60 times more energy than regular lightning. In other words, it was a huge burst of electricity flying straight into the sky. Most of the photos we have of gigantic jets come from satellites or astronauts on the International Space Station. But a few have also been captured from airplanes flying over storms. The latest jaw-dropping image was taken on November 19, 2024, by an astronaut aboard the ISS. At first, the picture wasn't released by NASA or any space agency. But one photographer, known for tracking and photographing rare lightning events, found the photo by accident. He was browsing through a NASA-run website called the Gateway to Astronaut Photography of Earth, which hosts photos taken by astronauts. There, he spotted images showing a giant lightning jet. Eventually, the photos were brought to public attention on February 26, 2025, and they've also been turned into a time-lapse video on YouTube. We still don't know exactly about the exact spot where the jet happened. Thick storm clouds covered the ground in the pictures. But based on where the ISS was flying at the time, the jet probably happened just off the coast of New Orleans. Speaking of other images of the gigantic jets, a photographer living in Puerto Rico was taking pictures of a storm moving through the area. That same storm would later grow into Hurricane Franklin. While watching the skies, he saw something truly amazing. Several massive lightning bolts shooting straight up out of the storm clouds, stopping just below the edge of space. No wonder. According to a 2022 study, gigantic jets happen most often in tropical areas, and they're more likely during fast-growing storms, like Hurricane Franklin. Gigantic jets often end with thin, red, branch-like lightning tendrils. These faint red flashes are very similar to another rare type of lightning called sprites. Those sometimes look like giant glowing jellyfish in the sky. In 2023, an astronomer named Stanislav Kaniansky in Slovakia captured one of the clearest images of a sprite ever. It happened during a thunderstorm over Central Europe on August 14th, and he spotted it near his home. In the photo, you can see a huge glowing red structure with zigzag patterns stretching over 31 miles across the sky. But like all sprites, it only lasted a fraction of a second before fading away. Sprites happen when lightning sends electrical energy upward into the upper part of Earth's atmosphere, instead of just downward like regular lightning. This energy creates glowing strands of plasma, which is basically electrified gas, way up in the ionosphere. Since sprites are so fast and often hidden by thick clouds, they're very hard to photograph. But Kaniansky got lucky. The thunderstorm was about 200 miles away from him, so he had a clear view just above the tops of the storm clouds. That perfect angle helped him capture this stunning phenomenon. There are many different kinds of lightning, and some of them are not only rare but also super dangerous. Let's take ball lightning, for example. It's exactly what it sounds like, a glowing, floating ball of light that appears during thunderstorms. It's also one of the weirdest and most mysterious forms of lightning. People have seen these strange light balls, usually about the size of a grapefruit, slowly spinning or hovering just above the ground. Some even say they've seen them float through closed windows or suddenly appear indoors, then vanish after about 10 seconds. For hundreds of years, no one really knew what caused ball lightning. Scientists had no explanation, and most sightings were based on eyewitness stories. Then, in 2012, someone finally managed to capture ball lightning on camera. Since then, different ideas have come up to explain what ball lightning really is. One of the newest theories suggests that the ball is actually a tight bubble of super compressed air. This compressed air bends and spins white light in all directions, making it look like a glowing ball rolling around in the sky. And according to the researchers, ball lightning can be almost 1 billion times more intense than regular lightning that moves in a straight line. Then there are elves. They look a lot like sprites, but instead of looking like jellyfish or dancing shapes, elves appear as huge glowing rings or halos in the sky. And they're massive. An elf can spread out to be up to 185 miles wide. You can even spot them from space or through thin clouds during the day. Dark lightning is probably one of the strangest types of lightning, and most people don't even know it exists. Unlike regular lightning, it doesn't produce a bright flash. Instead, it gives off intense bursts of radiation, especially gamma rays, the most energetic form of light found in nature. Dark lightning happens when high-speed electrons slam into air molecules inside a storm cloud. This creates a burst of gamma rays. They're so strong that they can mess with satellites hundreds of miles away in space. In rare cases, when a plane flies through a thunderstorm, these flashes can hit the aircraft. Some passengers could get a quick dose of radiation, about the same as a full-body CT scan. But worry not. Scientists say these occasions are extremely rare and not a reason to be afraid of flying. And finally, there's positive lightning. You see, lightning is still kind of a mystery, even for scientists. But here's the basic idea. Inside a storm cloud, tiny pieces of ice bump into each other and build up electric charges. Some become positive, others negative. Most of the lightning we see comes from the bottom of the cloud, where there are lots of negative charges. These reach down and zap the ground. But sometimes, lightning comes from the top of the cloud, where positive charges hang out. That's called positive lightning, and it only makes up about 5 to 10% of lightning strikes. Most of the time, those positive charges just zap other parts of the cloud, but sometimes they shoot all the way down to the ground. That's why positive lightning can strike even when the sky looks clear, because it comes from way up high in the cloud, sometimes miles away from the storm itself. The scariest part is that regular lightning can reach about 300 million volts, while the charge of positive lightning can be up to 1 billion volts. That means positive lightning is much stronger and more dangerous.
Look up. Find that little yellow dot. That's Titan. It's Saturn's largest moon and the second largest moon in our whole solar system. And it might be the only place in our solar system where there's liquid water, besides Earth. Plus, it has an atmosphere that serves as a shield against solar radiation and cosmic rays, just like Earth. If life was a house, Titan would have a lot of the bricks you'd need to build it. Strap in, you're heading over there. It takes a long time to get to Titan, but you know, the magic of YouTube. Here it is, a bit bigger than our moon and a whole lot heavier. It's even bigger than Mercury. That means its gravity is still pretty weak. You'll feel 7 times lighter here than on Earth. At the local gym back home, you can lift 150 pounds. On Titan, you can lift more than 1,000. Ha! Looking good. The surface is mostly made up of ice. It has small mountains, craters, and a few cryovolcanoes. Basically, the same as a regular volcano, but instead of lava, this beast spits out water, ice, ammonia, and methane. There are lakes and clouds, kind of like a canyon would look like on Earth. But here, there's only a tiny difference. Everything is covered in thick fog, and sometimes it hails frozen methane. On Earth, we use methane as fuel because it burns. But on Titan, there's no oxygen. Can't get a fire going on this hunk of rock. No oxygen means you need to put on an oxygen mask, but you don't have to wear a whole spacesuit like on our moon. Titan has a stronger atmosphere. But you packed a sweatshirt, right? It's gonna get pretty cold soon, like -300 degrees cold. The coldest it ever got on Earth was -128, and that was right at the South Pole. It's so cold because it's so far from the sun, almost 900 million miles. Anyway, that dense fog and atmosphere stop the sun's rays from warming the surface. Sounds kind of extreme, but so is life. It can survive almost anywhere. Take the bacteria Dano, some long Latin word. It can survive radiation and extremely low temperatures. It even survived a whole year in outer space, on the outside of the International Space Station. Titan would be a piece of cake compared to that, especially if we drilled down a bit. Many scientists believe there's a whole ocean under the surface of Titan. Saturn's gravity gives Titan's core a little heat boost. Plus, there's ammonia in that ocean. It's like Titan's version of antifreeze. As long as the water stays liquid, life's got a pretty strong chance of success. So what's down there? Scientists have actually found real evidence that Titan might already have life on it. Here, check out this microscope. This is C3H2. It was discovered by this weird group of antenna things living in the desert in Chile. It used 66 antennas, all pointed at the same place in the sky. This C3H2 molecule can act as a building block for DNA, the code of life. Some people think that these molecules were around on our planet billions of years ago, just when life began. Scientists also checked it out firsthand with a probe that actually landed on Titan. Turns out those desert antenna things were right. Titan shot to the top of the list of places we could one day live on. Sorry, Mars. NASA has a new project, the Dragonfly mission. They're gonna send a drone out there and explore Titan even more. The mission's still about 6 years away, and the rocket will reach Saturn's moon 9 years after that. So we're gonna have to wait a while before we pack up and move to Titan. After the Dragonfly drone lands on Titan's surface, it's going to whiz around like a sort of double helicopter. It's going to have 8 propellers, 3 feet wide. Since there's weak gravity, that's more than enough to give the drone good cruising speed. It'll be able to fly about 2 miles straight up, and take off and land vertically, like a regular helicopter. The main problem with the whole thing is the drone's batteries. Scientists invented a generator that converts thermal radiation energy into electrical energy, whatever that means. One battery charge should be enough for several hours of continuous flight. The Dragonfly is going to be carrying a lot of research equipment, so it's not like those drones people fly in the park on a Sunday. It's going to weigh about as much as 3 ostriches. It's going to have 2 drills, a bunch of sensors, a spectro thing to find out what chemicals are lying around, and it's also going to have its own weather channel with a ton of instruments to measure temperature and clouds and stuff. And like any gadget nowadays, it has a camera on it. Get ready for some beautiful pics of Titan's epic landscape. Nighttime on Titan lasts about 8 Earth days. That's when the drone's going to be relaxing on the surface, recharging and analyzing samples. That's a long time, but it's actually a good thing. Titan's distance from Earth causes a bit of a problem, a delay in communication. When they send the Dragonfly a signal from Mission Control, it has to fly halfway across the solar system. Takes over an hour. In contrast, the signal delay to Mars can be as little as 10 minutes, and the signal delay to the Moon is only about a second. Scientists expect Dragonfly to provide more information about whether we can live on Titan or not. Some experts hope to find a primordial soup there. It's a whole mush of stuff needed to make life. We had that same soup on Earth about 4 billion years ago, and every single living organism that ever existed evolved from this mush of organic elements. If the Dragonfly project's a slam dunk, and Titan does turn out to be habitable, it'll have one more mission, to find a nice place for us to settle down in. But creating a self-sustaining colony on another planet would definitely be the hardest thing humans have ever done. First hurdle, energy production. Probably some sort of nuclear power plant. Then comes shelter, for humans and their machines. Those new Titan buildings will have to protect us from the extreme cold and bad weather. Then, drinking water and oxygen. We'd need to invent a way of collecting or engineering both. Then, greenhouses for growing food. We'd also need to mine fuel for transportation. Luckily, Titan's packed full of methane, which is great for fuel. One huge problem, gravity. Because it's so weak on Titan, whoever lives there could lose a lot of muscle mass, making it hard to work and even just live. And there are those pesky cryovolcanoes shooting stuff out at random times. Or maybe we'd need a more drastic, daring idea. How about changing Titan's atmosphere so we can breathe on it and not have to wear about 100 hats and gloves? To do this, we'd need to terraform Titan's surface for a long time. Titan's atmosphere needs to be enriched with oxygen for us to breathe, and it would be great if it was a bit warmer. The next step is to create a biosphere, which means plants. We could turn Titan into a blooming jungle with plants brought over from Earth. But because of pressure and gravity, they'd look completely different from Earth plants. They might all grow super tall, or maybe they'd all shrink down to mini size. We really don't know. First things first, we need to make sure that life is even possible on Titan. Scientists recently thought there might be life on Venus. It's sort of the same size as Earth, and scientists even call it Earth's twin sister. They discovered a gas on Venus, phosphine. Supposedly, it was made by living organisms. Turns out it wasn't true. Well, not really. There is some phosphine floating around, but way less than we first thought. Look, science on other planets is super hard, people. We're always making mistakes like that.
Now, I'll bet you remember the furthest planet from the Sun is Neptune. When European astronomers argued about what to call the newly discovered eighth planet back in 1846, they settled on the name of the Roman deity of the sea. This ice giant is 4 times the size of Earth. And if our planet was the size of a nickel, Neptune would be as large as a baseball. At the same time, the ice giant is 17 times as heavy. If you were approaching this icy world, it would seem blue and perhaps inviting. But this blue surface is actually a layer of swirling gas and permanent clouds. So don't get your hopes up. you wouldn't be able to land on this planet. Its mantle, made up of water, ammonium, and methane ice, is the closest thing Neptune has to a surface. But even down there isn't solid ground for you to walk on. Anyway, this distant planet is surrounded by mystery, and astronomers haven't cracked all of it yet. Why are the winds on Neptune so fast? Why does this world shed more heat than it gets? Why is its magnetic field offset? And what is the Great Dark Spot? Well, let's try to find some answers. Neptune is around 30 times as far from the Sun as our home planet. That explains why studying this distant world is so difficult. It also means that the planet gets way less light and heat from our star. But at the same time, Neptune radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers don't know for sure why it happens yet, but of course there are theories because they're scientists. Some experts believe there is something fierce inside the blue planet that causes it to generate more heat than it receives. It might be the reason for Neptune's huge differences in temperatures, from minus 260 degrees Fahrenheit at the planet's rigid cloud tops to more than 12,000 degrees at the core of the ice giant. So you're going to want to dress in layers. Now, such temperature variations might be the reason for powerful windstorms. Their speed can reach 1,200 miles per hour. For comparison, the most powerful winds on Earth move at a speed of 250 miles per hour. Another curious thing about Neptune's winds is that they are blowing westward, which is backward to the rotation of the planet. A study published in 2013 supposed that the winds on Neptune would appear in thin layers no more than 600 miles thick. Such a shallow depth might mean that condensing and evaporating moisture could produce those crazily fast air currents. Then there's the issue of Neptune's magnetic field being offset. If you were to overlay a magnet on this planet, it wouldn't line up with the center. Astronomers aren't sure why it happens. Magnetic fields are produced by moving currents, and all the planets, including Earth, are believed to have some conductive material moving in their bellies. But with Neptune's belly, it's a bit different. Its magnetic field is tilted at 47 degrees to the planet's rotation, which means that the rotation and magnetism aren't aligned inherently. And don't forget about the Great Dark Spot. No, I'm not talking about the most massive storm in the solar system. That one is called the Great Red Spot and is located on Jupiter. I mean a corresponding spot on Neptune discovered by Voyager 2 in 1989. In 1995, the Hubble Space Telescope turned its eye on Neptune, but disappointingly, by that time, the spot had already mysteriously vanished, and scientists have no idea how exactly it disappeared. But guess what? Another dark spot has been found on the ice giant. Astronomers have known for quite some time that, from time to time, Neptune's surface gets dotted with such spots. These bizarre discolorations have been linked to high-pressure areas coming and going over the course of a few years. But no one has seen a dark spot forming until recently. Since then, astronomers have been observing the birth of dark spots quite regularly. Now they have a much better idea of where and when these huge vortices might form. Now, despite assumptions, astronomers once thought Neptune was a boring, featureless world. The ice giant has a hyperactive atmosphere. It's turbulent, with cloud ripples and severe storms. Plus, this planet has a ring system. Disappointingly, those rings are not distinct hula hoops circling Neptune, like those of Saturn. The ice giant's rings are weirdly chunky and contain gobs of material that form arcs in the outer ring. Astronomers explain that these clumps are actually places where loads of ring particles are stuck together. What it means is still unclear. But my favorite thing about Neptune is this one. Astronomers believe that deep inside the planet, there might be a layer where it rains diamond crystals. Intense pressure and temperature inside Neptune break methane molecules apart, releasing carbon. These carbon compounds find their fellow molecules and create long chains, which then get squeezed together, forming beautiful crystalline patterns like diamonds. When these diamond formations drop through the layers of Neptune's mantle, it gets too hot for them. That's why they vaporize, float back, and, you guessed it, repeat the cycle. Now you know why it's called diamond rain. How about a fun little experiment? Let's say we exploded Neptune, in the name of science, of course. As you already know, this planet doesn't have a solid surface. That's why, after activating the process, you'd see Neptune's liquid mantle burst. It would look like a water-filled balloon thrown down from the 50th floor. Disclaimer, don't do this at home. The impact would send splashes of water, ammonia, and methane ice away into space. It'd be followed by lava-like remains of the planet's mantle, liquid and red-hot. And then there would be a hurricane of solid rocks. That's what would be left from Neptune's solid core made up of iron and other metals. Okay, let's put this pretty ice giant back together. I've got one more experiment for you. Let's replace the Moon, yes, our good old satellite, with Neptune. The ice giant is definitely way larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, and we would see it not only at night but also during the day. It would appear to be 15 times larger than the Sun. If everything else remained the same, solar eclipses would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. And since Neptune is also much more massive than Earth, its gravitational pull is much stronger. That's why, instead of getting itself a powerful companion and protector, our planet would end up as a satellite. Yep, Neptune's moon. It would orbit Neptune slightly further than its own largest moon, Triton, and there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with any of Neptune's satellites. Even so, we would have more than enough problems. Tides on our planet would be 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. Like we need more of that, huh? The seismic activity would increase, setting off earthquakes and volcanic eruptions. Well, that sounds unsettling. So let Neptune remain where it is now. I'm okay with a good old moon. Now we're done with the experiments, but hear me out. Beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding another big planet from our sight. Are they in cahoots? This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot, it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers modeled how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stunned. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble Telios, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Telios is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star, called a white dwarf, starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Telios. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Telios doesn't show any. Not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Telios might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Telios looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Telios is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing. Telios' nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Telios be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about Type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Telios. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues, how bright the thing is, how big it looks, and how far it might be, and none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Telios can exist, what else is out there, waiting to challenge everything we know about the universe?
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b, and astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620 26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus,
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
Prepare for blast-off, because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now let's check out Titan's celestial credentials. It's not just any moon. It's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It'll feature the Drill for Acquisition of Complex Organics, DRACO, instrument, which will help us scoop out material from Titan, while the Dragonfly Mass Spectrometer, DRAMS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious, dense atmosphere that kept everyone on their toes. Now let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there. So all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor, literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say, the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper Belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are 2 possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years.
You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings, wedding rings, rings on the tub. She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. #EarthRings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the Sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to Sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing. Everyone to your homes now! This is not a drill! Everyone, head home! You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This ice age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only 1 more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new Ice Age has just begun. One year later, you're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the Ice Age might be over soon. Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So people approach the rings, but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between 2 colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroid smashes the station. Well, seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then, people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then, a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of 100 years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years, and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller but weaker. People's skin would be pale because of the lack of light, but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there. So astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now, this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now, they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch, or the fawn, in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new LEFBOT has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT2024WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole LEFBOT thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes: small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. LISA will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real. And they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science.
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the Sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the Sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the Sun and from space. But even though Saturn is protected by its magnetosphere, the Sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets. Why do we love Saturn so much? Right, because we love its amazing rings. The planet stands out in the solar system because of them. The major rings have a diameter of 170,000 miles, yet their thickness does not exceed 330 feet. Saturn's slowest outermost ring spins at about 37,000 miles per hour. It's slower than the rotation of Saturn itself. But did you know that Saturn was ringless for most of its history? Let's find out how they were formed. Using Cassini's final plunge into the planet, researchers could estimate the ring's mass. 33 billion pounds. Further, they have determined that the rings were between 10 to 100 million years old, much younger than the planet itself. The thing is that the rings only look solid. They are made of billions of rock and ice chunks. They are primarily tiny ones, looking like grains of sugar to those as large as a house, or even as mountains. The innermost chunks of ice and rock shoot through space at about 52,000 miles per hour. There are mysterious spokes in its rings. It seems they form and disperse within a couple of hours, and these spokes might consist of electrically charged sheets of tiny particles formed when small meteors hit the rings, or maybe electron beams from Saturn's lightning. One theory says Saturn's rings have formed all that extra material that remained after Saturn began, which is a material that couldn't create a moon. There's also a theory that says there was Theia, a Mars-sized planet that collided with Earth about 4.5 billion years ago. Lighter crust parts ended up in space during the impact, whereas its denser core stayed behind. But in the case of Saturn, all that debris perhaps didn't put a new moon together, but it formed rings many people today recognize this planet for. Another theory is that rings formed from dust and debris of a moon that ended up destroyed by this big impact, maybe by an asteroid or comet. Or perhaps the rings are there because once a moon fell apart because of the tidal forces coming from its parent planet itself. If these rings formed at the same period as Saturn did, they would have had more than 4 billion years to collect a bit of debris and dirt coming from micrometeorite collisions. But these rings mainly consist of water ice, no dirt at all, which means they're younger than expected. And the nature of this ring system tells us a thing or two about Saturn's fuzzy inside. Fuzzy means its core is like sludge. The helium and hydrogen in Saturn mix with more and more rock and ice over time, the closer you go to the planet's core. It's similar to what you see in our oceans. The deeper you go, the level of saltiness increases. But the rings may disappear in the far future. Rings are generally more common than we think. Jupiter, Uranus, and Neptune all have their own ring system. But not every planet has the same ones. Saturn has a fascinating halo, and definitely the most spectacular rings, true. Others mostly have rings made of dust and rocky particles, and not just planets. Other space bodies can have rings, like the asteroid called Chariklo. But even though the gas giants of our solar system have rings, rocky or so-called terrestrial ones don't. And one theory says it might have been that way because gas planets in the outer area of the solar system protected those rocky ones that formed in the inner solar system from all those collisions that possibly could have formed rings around them. Or it could be because gas giants are way bigger and their enormous volume allows them to have a ring system that can remain stable. And what if Earth had rings in the past too? Maybe in the time of the big collision when our moon could have been formed. Now to some more cool things happening in our solar system. Pluto, a tiny dwarf planet at the edge of our solar system, also the one we used to call a planet, has a pretty bizarre atmosphere. No one expected to see a haze there go as high as 1,000 miles. That means it rises higher above the surface of the atmosphere of our home planet. And the atmosphere on Pluto has around 20 layers. They're more compact and way cooler than scientists expected, and tons of nitrogen gas escape Pluto by the hour. But the dwarf planet still finds a way to constantly create new supplies of all the nitrogen it had lost. One theory says it probably produces these supplies through geological activity. Our moon is pretty peaceful, but that's not something we can say for Io, one of Jupiter's moons. This one has hundreds of volcanoes. It's the moon with the most volcanic activity in our solar system. Io sends plumes of sulfur up to an incredible 190 miles into its atmosphere. Its volcanoes emit many particles and gases into the space right next to Jupiter every single second. Its eruptive activities happen because of Jupiter's mighty gravitational forces and magnetic field. The insides of Io tense up and relax all the time, depending on how close or far away it is from Jupiter. And that's why it generates enough energy to have such an eruptive nature. Speaking of volcanoes, Mars has one larger than the whole state of Hawaii, At first, you'd probably say it's a quiet and peaceful planet. But once upon a time, enormous volcanoes dominated its surface. Yup, that includes a well-known Olympus Mons, the largest volcano ever found in our entire solar system. 374 miles across, comparable to the size of Arizona. Olympus Mons is 16 miles high, 3 times the height of our tallest mountain, Mount Everest. And by its volume, this volcano is 100 times bigger than the largest one on Earth. Mars can have such big volcanoes because its gravity is significantly weaker than the one on our home planet. Also, the crust on Earth moves all the time, unlike the Martian crust. Do you know how the Hawaiian Islands formed? A hot spot in the mantle created a chain of volcanoes in the crust floating above it. A Martian volcano may grow bigger because its surface isn't moving, so a volcano could build up for a longer time in just one spot. Miranda is one of the most bizarre moons in the outer part of our solar system. It's a shadowy moon that orbits Uranus with many craters, sharp ridges, and similar disruptions on its surface. Usually, this type of relief tells a certain area used to have a lot of volcanic activities. But that wasn't the case with Miranda. Also, this moon is way too small to generate tectonic activities. Another element that could form this type of surface. One theory says the gravitational force from Uranus could have caused the push-pull action, something that made all these bumps on Miranda's surface. We'll have to send another spacecraft to find out what was happening there. We are all made of stardust. 97% of atoms we're made of are the same as the material our galaxy consists of. The building blocks of life is a term we use for a group of elements that are vital for life on Earth. And stars have these elements too, but in different proportions. For instance, we are 65% oxygen by our mass, whereas elements we measure in space, like the spectra of stars, have less than 1% of oxygen. So, Mercury is already the smallest in our solar system in the planet category, excluding some other bodies like the dwarf planet Pluto. And now it looks like it's still shrinking. It's the second densest after our planet, but it's getting denser over time. Researchers thought the Earth was the only planet in our solar system with tectonic activities for a long time. And now we know Mercury is tectonically active too. Messenger spacecraft managed to map the whole planet. Scientists realized the planet is full of fault scarps, some cliff-like landforms. Since these are relatively small, they're probably young, and Mercury is still contracting even 4.5 billion years after our solar system was formed.
This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water, should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand, others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing toward the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the Moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ring planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. 2 of them, Pandora and Prometheus, flank the F ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But 2 of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So, maybe we take that effort and save us from a real threat, climate change. Just saying.
Way out by Saturn, there's an icy moon called Enceladus. And it's literally spitting out ice into space. And that ice contains the stuff life's made of. Oh, and there's a whole ocean hiding under the ice. And who knows what's living in it. Enceladus is only about 300 miles across. It could literally fit inside the state of Colorado. But even though it's super small, it's got liquid water, energy from hydrothermal vents, and a bunch of chemicals that could actually support life. In other words, it's one of the best spots in the solar system where life could exist. Now, rewind about 20 years. NASA's Cassini spacecraft flew by Saturn and noticed something strange. Enceladus was shooting out little jets of icy particles from cracks near its south pole. Later, scientists realized those jets were coming from a giant underground ocean beneath the moon's surface. When they analyzed the frozen grains from those plumes, they found almost all the elements needed for life: carbon, hydrogen, nitrogen, oxygen, and phosphorus. Only sulfur was missing. The only problem was, most of those samples came from Saturn's E-ring, a huge ring made of dust and ice that surrounds the planet. And those particles had been sitting out there for decades, maybe centuries, meaning they could have been changed by space radiation. So no one could say for sure if those life ingredients really came from Enceladus itself. But now that's changed. A new study has just confirmed that fresh ice grains, the ones newly blasted out from Enceladus, contain organic molecules, including stuff like nitrogen and oxygen. Here's how scientists figured it out. In 2008, Cassini flew right through one of those icy geysers, and it literally got splattered with tiny particles. They hit the spacecraft's dust detector at insane speed, 11 miles per second. That's fast enough to separate all the molecules, so the team could see what they were really made of. Then the scientists used a technique called mass spectrometry and managed to study those fresh grains in detail. They found molecules that on Earth are part of certain chemical reactions. Those build the complex structures life needs to exist, including ones that may contain nitrogen and oxygen.
One of the researchers said that this likely proved that those complex organic molecules hadn't formed in space. They might have actually been coming straight from Enceladus's ocean. Another scientist explained that those molecules could play an important role in biological processes. All this means that Enceladus might really be habitable, But even if there's no life there, that's still a big deal. Because then we have the right to ask, wait, why isn't there life when all the right conditions are in place? The story doesn't end there. The European Space Agency is already planning a future mission to actually land on Enceladus, right at its south pole. They want to scoop up more samples and see what's really going on under all that ice. The launch is planned for sometime in the early 2040s, so in just a few decades, we might finally find out whether this tiny frozen moon is home to some bizarre life forms. But Enceladus isn't the only potentially habitable place we know about. Admittedly, the others are beyond the edge of our solar system. Like 3 possible super-Earth planets orbiting a nearby orange dwarf star. Now, super-Earth is just what scientists call planets that are bigger than Earth but smaller than the icy giants like Uranus and Neptune. Scientists from the University of Exeter found that those exoplanets were orbiting their parent star, HD 48498, which sits about 55 light-years away from Earth. That's practically our cosmic neighborhood. Each of these planets takes a different amount of time to go around its star. One needs 7 Earth days, another 38 days, and the last one 151 days. And the coolest thing is that the outermost planet might actually be hanging out in the star's habitable zone. That's the sweet spot where it's not too hot and not too cold for liquid water to exist. It means the planet's surface could be comfortable enough for water to exist without boiling or freezing. This makes it a great candidate for life as we know it. Over 10 years, the team collected nearly 190 super precise measurements using cutting-edge equipment that looks at the light coming from stars. By checking whether the star's light is slightly shifting toward us, this is called blue shift, or away from us, that's red shift, they can figure out if a planet is tugging on it. The host star itself is an orange dwarf, something like our Sun's smaller and calmer cousin. It's similar to the Sun in many ways, but as an orange dwarf, it gives off less radiation than our yellow dwarf star does. The coolest part is that this is one of the closest planetary systems we've ever found that hosts a super-Earth in the habitable zone around a Sun-like star. Now, super-Earths aren't exactly rare. Scientists have found over 6,000 exoplanets since the first one orbiting a Sun-like star was confirmed in 1995. To spot such distant worlds, astronomers use all sorts of tools, like NASA's Kepler telescope, launched in 2009 to find Earth-like planets in the Milky Way. Let's sneak a peek at some of the most exciting exoplanets out there. Gliese 667cc is only 22 light-years away, even though that's still about 129 trillion miles from us. It's about 3.8 times the mass of Earth, and zips around its red dwarf star in just 28 days. So a year there is 13 times shorter than ours. Its red dwarf star is cooler, and the planet probably sits in the habitable zone, though occasional stellar flares could give it a sunburn. Kepler 22b is way farther out at 600+ light-years. It was the first Kepler planet found in a habitable zone. It's about 2.4 times bigger than Earth, and we still don't know if it's rocky, liquid, or gaseous. Its orbit is close to Earth's, taking 290 days to circle its G-class star, smaller and colder than our Sun. Kepler 69c is a whopping 2,700 light-years away. This planet is almost 70% larger than Earth. Its orbit takes 242 days, putting it in a Venus-like spot in its system. But since its star is only 80% as luminous as our Sun, the conditions on that planet might be way friendlier than those on Venus. We discovered TOI 733b in 2023. This world is about 245 light-years away. It orbits its star super fast, taking just 4.9 Earth days. But the coolest thing is that it might be completely covered by a massive ocean. Could there be life in that ocean? Time will tell. GJ 1214b is 40 light-years away, pretty close by space terms. The planet is almost 3 times Earth's diameter and 8 times as heavy. It needs 38 hours to orbit its red dwarf star. The surface temperatures there hit 450 degrees Fahrenheit And with all that heat and pressure, water behaves in crazy ways, like hot ice or superfluid water. By the way, that superfluidity is wild stuff when water moves like magic without friction. But don't try it on Earth. You'll just get dehydrated. Proxima Centauri b is the closest super-Earth, sitting at just 4 light-years away. It has a similar mass to Earth's, but a year there is only 11.2 days. Its star even wobbles a bit thanks to the planet's gravity. That's actually how scientists discovered it. The planet sits in the habitable zone but gets blasted by extreme UV radiation because it's super close to its star. Right now we can't even study its atmosphere. And finally, TOI 715b. This one orbits a red dwarf, which is smaller and cooler than our Sun. These tiny stars are pretty great for finding habitable worlds because planets can orbit close without frying. TOI 715b may have once had a super thick atmosphere like Neptune's, but it might now be losing it. Scientists need more research to see if it's now a watery, rocky world. In any case, some of these planets might have oceans, some might be way too hot, and some could even be our distant cosmic cousins. Either way, each discovery helps us understand the universe a little better. And who knows, maybe someday we'll even set foot on one of those super-Earths.
You look up at the night sky and see nothing. Okay, well, it's not nothing. You see stars, but not nearly enough. If the universe is filled with endless stars in every direction, why isn't the sky blazing with light? That's just one of many cosmic riddles that are still waiting for an answer. Why do black holes delete information? Why can't the universe agree on how fast it's expanding? Yeah, these paradoxes break rules so much that it feels like they're breaking reality itself. The universe is endless, right? Just stars on stars on stars stretching out into infinity. Well, if that's the case, then how come the night sky isn't lit up like Times Square on New Year's Eve? That's the heart of Olbers' paradox, named after 19th century astronomer Heinrich Olbers. He wasn't the first to notice the problem, but he made it famous by basically asking, if there are stars in every direction, shouldn't the whole sky be glowing? You might think they're just too far. But in an endless universe, every direction should eventually hit a star, and all that faint light should add up. So, why the darkness? Maybe the answer is that the universe isn't infinite in time. It had a beginning, the Big Bang. That means light from the most distant stars hadn't had enough time to reach us yet. And the light that has been traveling for billions of years, it's been stretched out so much by the expanding universe that it's now invisible to our eyes. So, that pitch black sky, it's not empty. It could be that it's full of light we just can't see. Maybe it's a clue, a sign that the universe has a beginning, a history that we have yet to uncover. Alright, so space is darker than it should be, but you know what's even weirder? It's also way too quiet. You probably wondered about this since elementary school. Okay, the universe is massive. There are billions of stars with planets orbiting them, and a bunch of those planets should be kinda like Earth, which means extraterrestrials, right? So, where are they? This is what we call the Fermi paradox. Back in the 1950s, physicist Enrico Fermi sat down and asked himself this very question. There are no signals from outer space, no laser beams, no weirdly coded messages, nothing. It's not like we haven't tried to say hello. In 1974, scientists used the giant Arecibo radio telescope to beam a binary-coded message into space. It included stuff like our DNA structure, a stick figure of a human, and even Earth's location in the solar system. And since sound can't travel in space, what we actually sent were radio waves traveling at the speed of light. The message is heading to a star cluster 25,000 light-years away. So even if those little green men pick it up the moment it arrives, the earliest we could get a response is in about 50,000 years. Okay, that's pretty far into the future. But wait, if we're out here sending signals, isn't it possible someone else did the same, like 150,000 years ago, or 500,000? Shouldn't something have reached us by now? Some extraterrestrial TikTok at least? The answer could be that we're the first technologically advanced civilization. Perhaps intelligent civilizations vanish with their stars. Or maybe they're not as friendly as we are, and they've been avoiding us for a reason. Here's a nerdy one. Maybe they're out there, but we're just not listening the right way because it's not us being advanced enough. What if extraterrestrial civilizations communicate using something completely different from what we do? Like quantum entanglement or some exotic tech we haven't even dreamed of yet. Or maybe they exist in a form we can't even comprehend. Anyway, let's move from the silence of space to its most terrifying feature, black holes. You've probably heard the basics. Black holes are regions of space where gravity is so intense that not even light can escape. But here is an interesting theory. Black holes might be breaking one of the most sacred rules in all of physics. It's called the black hole information paradox, and this one made my brain hurt. In quantum physics, there's a rule. Information can't vanish. Not diary secrets, but the data describing every particle's position, spin, and motion. The whole essence, so to speak. Even if you destroy something, like burning a book to ash, the atoms and energy are still around. And in theory, big emphasis on theory, if you had super advanced tools, you could still figure out what was written in that book based on the particles and energy left behind. But when something falls into a black hole, a star, a spaceship, a giant pizza, whatever, it disappears behind the event horizon. And then, over time, the black hole itself slowly evaporates by releasing tiny bits of energy called Hawking radiation. Here's the problem. Hawking radiation dribbles out like random static, carrying no obvious hint of what the black hole swallowed. And if the black hole disappears completely and that information never comes out, it's like the universe just deleted the file with no backup. That breaks the no information loss rule. Some scientists think the information might be hidden in the radiation, but scrambled in a way we don't understand yet. Others think it gets imprinted on the surface of the black hole. And some say maybe we've got something fundamentally wrong about how the universe works. Before we figure out that one, let's pull back from black holes and take a wider look at the universe itself. Because even the way it's expanding doesn't seem to add up. This one is called Hubble tension, and it's not about drama between scientists. It's about a simple question. How fast is the universe expanding? Now, this should be easy to measure, right? For people good at math, I mean. Turns out, scientists have two ways. One looks at the early universe using the glow left over from the Big Bang. The other checks how fast galaxies are moving today by watching exploding stars. Except here is something funny. Those two numbers don't match. You'd think maybe it's just a measuring glitch, like, oops, forgot to carry the 1, but nope. It's more like checking the speed limit sign and then pointing two radar guns at the same car, and both showing vastly different results. This cosmic disagreement might mean that dark energy, the thing driving the expansion of the universe, is changing over time. Or that there's some secret ingredient baked into the early universe we haven't discovered yet. Either way, the universe seems to be expanding in a way that breaks our models. So it's possible we're missing something big. Or that reality is playing by guidelines we haven't written down yet. Alright, we've talked about how black holes might erase information. However, there's something just as weird. What if things in the universe don't decide what they are until you look at them? That's basically the idea behind the observer effect. Imagine you're tossing tiny balls at a wall with two holes in it. You'd expect each ball to go through one hole or the other, right? But if those balls are actually particles, like photons or electrons, something weird happens. If no one's watching, they act more like waves, and they go through both holes at the same time. But the moment you try to watch them, they stop doing that. They choose one hole and act like regular balls again. It's as if reality holds its breath until we look, then locks in what it is. But were they? Or did our act of looking force the decision? Nobody's really sure. However, that's not all. We didn't even have time to get into the time symmetry paradox, where the math says time should flow both ways, but in real life, it only marches forward. Or the cosmic horizon paradox, which asks how far apart regions of the universe, too far to ever communicate, somehow ended up looking exactly the same. Or the simulation hypothesis, which, yeah, let's just say that one deserves its own video. These paradoxes aren't just cool thought experiments. They're clues, little cracks in the surface of reality